Hello learners, I welcome you all to this session on mean. Basically in this session we will talk about computation of mean, but before going to the session actually let me recapitulate what we have already done in the previous session. In the previous session we have discussed about what is statistics, and we have seen that statistic is nothing but collection, presentation, analysis and interpretation of data, right, the information, in a way that it can be used for managerial decisions. We have also talked about what is the data, what is the nature of data. We talked about the data set, and we have discussed that there may be three basic kinds of data set. One may be bivariate data set, the multivariate data set and categorical data set. We also discussed about datum and data point, and then we got a glimpse of what is a central tendency, right, and we tried to learn what are the various application of all these measures of central tendency which is used in business. In this session we are going to talk about different measures of central tendency, that is mean, median and mode, and then we will talk of the introduction of the averages of position, and we will basically focus on computation of arithmetic mean. How can you compute arithmetic mean in a given situation, right? So shall we begin? Fine. As we have discussed earlier, why do we measure the central tendency of data? So the purpose for measuring the central tendency of data is that we need a single representative of the entire data. The information, the whole set of information, it is called population. So when you draw samples for the population, sometimes it is not possible that you study the whole population. In that case, what do? You draw samples from the population. So the sample that you are drawing, various samples that you are drawing, right, again there are very many. So if you have to tell the nature of data, or if you have to represent the entire set of data with the help of one value, what do? You measure the central tendency of the data. So if we talk of the various measures of central tendency of the data, let me quickly tell you that there may be mathematical averages, there may be averages of position, and the third one is other averages, right. Other averages, we basically talk of mid-range. It is not generally used. Why it is not used? Because it talks about the average of two extreme values, which are often called as outliers in statistics, and it can show a result which is not very clear, or it is not a good representation of the entire data set. That is why generally calculating this mid range is avoided. So we basically depend upon, as statistician, we depend upon the mathematical averages and the averages of position. So when I talk of mathematical averages, it may be three kinds. One is arithmetic mean, which is called as simple arithmetic mean or mean also. The other may be geometric mean, and the third one is harmonic mean. We will discuss about each one of them maybe in different set of sessions. And these mathematical averages, again they can be either simple mathematical averages, or maybe they can be weighted mathematical averages. A detailed discussion we will have in for next sessions, not in this session. In this session we will only focus on the computation of mean, right. The second kind or type of central tendency or calculation, I would say, measures would be averages of position, wherein we try to divide the data, or we try to see the position of the data. That can be found out, that can be calculated with the help of either median or maybe the partition values. Like either you want to divide the whole data set into two parts, so that will be median. If you want to divide the whole data set into 4 parts, that will be quartiles. Likewise deciles in 10 parts and percentiles in 100 parts. And then we can also calculate mode. So these are the different measures of central tendency. Now before we actually learn how to compute the arithmetic mean, let me tell you certain important terms which is used. The data which you are going to use to calculate arithmetic mean may be grouped data and may be ungrouped data. As the name suggests, grouped data, that means there would be various sets of information, right, or maybe for similar or for one kind of information there are various representations. When we are talking of ungrouped data, it is also known as individual series. So ungrouped data means we are talking of individual series, whereas when we are talking of grouped data, that means we are talking of discrete series and continuous series. So I hope you must have understood by now what is individual series, what is discrete series and what is continuous series. To emphasize it further, let me make it more clear to you, more simpler to you. Say for example, if I am presenting a data and the data says that wages of 5 individual workers, and the names of the workers are A, B, C, D and E. So these are 5 individual workers and their wages are, say for example, 200 per day, 300, 250, 375, 400 and so on and so forth. So this is individual series. That means we are talking of only one person, say for example person A, Mr. A, who is receiving rupees 200 as daily wage. Likewise, there is another Mr. B who is receiving 250 per day, right. So there is only one person who is receiving rupees 250 per day. This is what we are presenting in that data. So then it is individual series. Say for example, I am entering into a class and I am asking about the grades or marks of the students, right. Why I am taking this example? Because then maybe it will be more easy for you to understand, easier for you, right. So if I say, come on, all students who have scored, say for example 90% of the marks, please raise your hand. So there may be 10 students who have raised their hands. Next, if I say all those who have scored 85, please raise your hand. So maybe there are 15 students who have raised their hands. So this will be called discrete series. Now, since I am talking in absolute terms, right, 95 marks, 90 marks, 80 marks, so that would be discrete series. But in many cases it happens that the data is so big, it's huge. So you want to group that data. Like say for example, when I say students who have scored between 95 to 100, and say for example there are 20 such students. In that case, what we are trying to do, we are trying to define a class interval. All students who fall within this class interval, within the class interval of 95 to 100, please raise your hand and say for example, I get hands of 20 students. So that will be continuous series. Now with the help of simple illustrations, we will be understanding it even more, and I will try to focus it with every illustration, why it is individual series, discrete series and continuous series. Shall we begin? Come on, let us see. Now let us talk of arithmetic mean first. As I said in the beginning that in this session we will be only focusing on arithmetic mean and computation of arithmetic mean. So as the word is suggesting arithmetic mean, that means it is just average. As a statistician call it mean or simple arithmetic mean, whereas if you call anyone, they will say average, and the answer is same. That means in arithmetic mean we are not doing anything, we are only calculating the simple or arithmetic average of a given set of data. So when suppose you are asked to calculate the average, say for example income of 5 people, as I suggested in the beginning, 5 workers who are working as in the beginning, what do? You add up all the values which are showing, say for example, since I said wages, in this case in the terms of statistics I will call it variable. So this is one variable data, and variable is what? Wages of individuals, wages of A, wages of Mr. B, Mr. C, Mr. D and Miss E. Alright. So these are the wages. So if you have to find out, compute the average, what do? You add up all the values of this variable. That means you add up all the wages which are received by these 5 individuals and then you divide it by 5, because number of observations are 5 in this case, number of people are 5 in this case. So this is simple way of calculating average, and this is what you do when you are trying to calculate arithmetic mean. Now it all depends whether the data which has been given, it is of individual nature or it is of discrete series or it is of continuous series. So, the method of calculation of mean in all these three different series will differ, right. So, mean is denoted by x bar. You write capital X, then you make a bar on the head of it or the above the x, and it is read as x bar. So, mean is denoted as x bar, and the values of the variable, they are denoted as x1, x2, x3, and since I said you have to add up the values of all these variables. So, when we add up, that means when we sum up, the summation is denoted as sigma in statistics. So, why I am telling you? Because suppose when we are talking of formula, then you can understand what is x bar, what is sigma, and what is n, that is number of observations. So, let us try to understand the computation of mean with the help of various examples or small illustrations. Shall we move ahead? Okay. So, right now we are trying to learn to compute arithmetic mean for ungrouped data, and ungrouped data means individual series. That means the number of observations are, it is not in numbers. If I say 5, so number of observations would be 5 only, or maybe I can say 5 workers, or I can say Mr. A, Mr. B, Mr. C, Mr. D, Miss E. So, I can represent it either way, right. So, say for example, in this illustration we have taken that the grocery store sells 5 different products. The profit per unit on the sales of each of these products is as follows, which I am going to tell, and you have to find out the average profit, or you have to find out the mean profit of the given data. And the data says that product 1 is fetching rupees 4 per unit profit. Product 2 of a company is fetching rupees 9 per unit profit. Product 3 is fetching rupees 6 per unit profit. Product 4 is fetching rupees 2 per unit profit, and product 5 is fetching rupees 9 per unit profit. In order to calculate the mean profit of 5 products of a particular company, say company X, what we are trying to do is we are trying to add the values, add the profit per unit, all the profits per units of all the products, and we are going to divide it by the number of observations. In this case, the number of observation is product 1, 2, 3, 4, 5. So, when I say product 1, that means it is a single product. Again, when I say product 2, that means it is a single product. So, in total how many products are there? 5. So, number of observations in this case is how much? 5. So, number of observations, as I told you earlier, it is denoted by n. So, if we talk of the formula, we will say that mean or x bar is equals to summation x upon n. Alright, that means 4 plus 9, which is the profit per unit of the respective 5 products, 4 plus 9 plus 6 plus 2 plus 9, all divided by 5, and when you add up 4, 9, 6, 2 and 9 again, you get the value 30. Is that right? Are you calculating with me? Alright. And then you have to divide with the number of observations, which is denoted as n in statistics, right, and the number of observation is 5. So, if you divide 30 by 5, you get a value of rupees 6 per unit. So, now you can say that company X is earning rupees 6 per unit from its 5 different categories of product. Is that clear to you? Is it fine? Alright. Now, let us move with some other example with different data set. Now, earlier in the previous example, we have seen that how to calculate data arithmetic mean in individual series. Now, we are talking of discrete series. As I said, in discrete series, what happens? The number of observations for one particular variable may be very many. Alright. So, for example, in this illustration, I have taken that the marks of few of the students are given. Alright. So, all students who have scored, say for example 10 marks, they are 8 in numbers. So, that means in a class of whatsoever the students are, 8 students, they have scored 10 marks in a particular subject, say for example statistics. There are 21 students who have scored 20 marks. There are 23 students who have scored 30 marks. There are 17 students who have scored 40 marks. There are 15 students who have scored 50 marks, and there are 9 with the score of 60, 5 with the score of 70 and 2 with the score of 80. Now, this is discrete series. Why? Because for each value of the variable, the number of observations are more than 1. It can be 1 or it can be more than 1. Alright. Now, we can calculate mean through 2 different methods now. One would be direct method and the other one is shortcut method. So, direct method, we do summation, we use the same formula, there is some difference which I will tell you. And the shortcut method is if you do not want to make your calculations very big, so you add up some steps, but your calculations will become easier. So, that is shortcut method. Let us try to understand how to calculate mean for this given set of data with direct method, right. So, in this case what did you do? The variable, that is marks in this case. So, value of the variables are, which is denoted at x, as I told you, the variables, alright, the values of those variables, they are denoted as x. So, it is given that x is 10, 20, 30, 40, 50, 60, 70 and 80. So, while computing mean in discrete series or maybe in continuous series, it is always preferable that you make a chart or you make a table, because when you make a table, the data becomes very presentable and then you can easily calculate and compute mean, median or mode, whatever you are trying to compute, right. So, we have made a table. In table first column we have written the value of x, which is 10, 20, 30, 40, 50, 60, 70 and 80, alright. Number of students or the frequencies, they are called as frequencies. As I said, for one value of the variable there may be very many frequencies, it may be 1, it may be more than 1. So, in this case how many students are scoring 10 marks? 8 students. So, the frequency is 8. Frequencies in Hindi we call it barambarta, that means repeatedness, alright. So, repeated students who have got 10 marks are 8. Again, for 20 marks the frequency is 21. 30 marks frequency is 23, 40 marks 17, 50 marks 15, 60 marks 9 students, 70 marks 5 students and 80 marks 2 students. And this column of your table represents that when you add up the frequency wala column, what are you getting? You are getting the number 100. That means in that class how many students were there? 100 students were there. So, total number of observations were 100. In this case the population is 100. So, the n is population or total number of observation is denoted by n, small n, alright. So, that is 100. Now, if you want to take average, you can't do it simply by adding all the values of x and dividing it by 100. The result that you will get will not be perfect, will not be right. So, what you need to do here is you need to get the total of the marks of each and every students. So, in this case what would you do? You will multiply x with f or f with x and you will get a value which is called as fx, which is shown in the last column if you see, right. So, when you multiply 10 into 8 is 80, 20 into 21 is 420, 30 into 23 is 690, 40 into 17 680, 50 into 15 750, 60 into 9 360, 70 into 5 you are getting the value 350 and 80 into 2 you get 160. So, now you have got the value of fx, right. Now, you have to sum this fx, you have to find out the total of this fx column. So, if we try to get the summation of this column fx, the number that we are getting is 3670. So, summation fx is 3670. Now, when we are trying to calculate mean, simple arithmetic mean for that particular data set which is given, how do we calculate? Here we would say that mean x bar is equals to summation fx, or maybe you can also call it sigma fx, which is basically what? Summation, sum total of fx. So, you will say x bar or mean is equals to summation fx upon n. So, in this case summation fx we have calculated, it was 3670, whereas the number of observations which is n is how much? 100. For 100 students, the marks is 3670. So when you divide 3670, that is 3670 by 100, what do you get? You get 36.70 marks. So this is the mean of the marks of the students of a particular subject, right? So this was one method of calculating it, which is called as direct method. Now we can also use shortcut method to calculate this data. When we use shortcut method to calculate this data, as I said, number of steps would be increased, but your calculation would be simpler. Like in place of thousands, maybe it is in 2 digits number only, right? So let us see how do we do that. Are you ready? All right, let us move. So same data set, we are using different method. In this method, what do we do? X, values of X are given 10, 20, 30, 40, 50, 60 and 70 and 80. Number of observations are same because the data set is same, 8, 21, 23, 17, 15, 9, 5 and 2 respectively. Total number of the observations are 100, alright. Now, in this case, what do? We try to take assumed mean. We assume that this would be the mean, alright. So in this case, in this data set, you can take any of the number, value X which is given, first column if you see. So 10, 20, 30, 40, 50, 60, 70, 80, you can take any number, any value as assumed mean. It may be you can take it as 10, you can take it as 80, 70, 60, 40, whatever. But to make the calculation simpler, what do we suggest? That we should try to take some mid number value. Right? Say for example, in this case you can take 40 or 50, that will make your life easier in terms of calculation. So in this case, in this example, let us suppose that we are taking the assumed mean as 40, alright. So now what we are doing, we are trying to calculate the deviation of X from the assumed mean. So we have taken assumed mean is 40, so we will try to calculate the deviation. Deviation, how do we calculate? We will calculate X minus 40. X is the first column, the values are given. So with each value, what do? We will minus it with the assumed mean, and assumed mean is 40 in this case. So what do? 10 minus 40, and the value comes as minus 30. What we have done, what we have calculated? We have calculated the deviation of X, right? So that has come as minus 30. Likewise, 20 minus 40 is coming as minus 20, 30 minus 40 is coming as minus 10, 40 minus 40 is 0, 50 minus 40 is 10, 60 minus 40 is 20, 70 minus 40 is 30 and 80 minus 40 is 40. So you have got the value D, which is deviation. Now what would you do? You have to multiply this D with F, and you have to find out FD, that means F into D, frequency into deviation. Rather than multiplying X into F, what you have done in this method, you have calculated the deviation of X, and then you are multiplying F into X, or F into D, sorry, F into D. So what do you get 8 into minus 30, and you get a value of minus 240, as in the case you can see. 21 minus 20, and you get the value of minus 420. 23 into minus 10, and you get minus 230, right? Likewise, if you see, you've got the values 150, 180, 150, 80. Should I need to tell you that all the minuses will be grouped, added together, all the pluses will be added together, and the difference of 2 would be summation FD, right? And in this case, the summation FD is coming as 330. In the earlier case, it was coming as 3600 and something. In this case, 3670, and in this case, your calculations had gone shorter. Steps you have increased, but the calculation is shorter, and you get the value of 330. So FD is 330. But since in the beginning you have assumed a value as mean, so you have to factor that in here in this method. So the formula would be mean is equals to assumed mean plus summation FD upon n. So in this case, if you see the table, you will get the value. Assumed mean is 40, right? Since FD is coming into minus, so 40 minus हो जाएगा यहाँ पर. 40 minus 330 upon n, that is number of observations, which is 100, and the value comes at as 36.70, and the answer is mean marks of the students is 36.70. Do you realize that both the answers or answers that we have calculated through both the methods are same, 36.70. So this is just another way, another method of calculating arithmetic mean in discrete series. Now we will talk of continuous series. How do we compute or calculate mean in continuous series? So students, have you practiced till here? Shall we move forward? Alright, let us move forward. Now we will talk of arithmetic mean for continuous series. In this illustration, if you see, we have taken an example that weekly sales of 50 salesmen of a company are given below. Calculate the arithmetic mean by direct method, by shortcut method, and the step deviation method. Calculation is same, only the way of calculation may be different, just to reduce, just to shorten the numbers, all right, so that your computation becomes easier. So we will see how with the help of these three methods we can calculate or compute arithmetic mean in a continuous series data set. As I said, total sales is in rupees 1000. So from 0 to 5000 there are 3 salesmen who are selling this. From 5000 to 10,000, 6 salesmen. From 10,000 to 25,000, 25 salesmen, and from 25,000 to 50,000, 10 salesmen. So this is the data set which is given. Now let us see how do we calculate mean in this case. The value is of course what? Sales, and sales is given in class interval, that is 0 to 5000 or 0 to 5, 5 to 10, 10 to 25, 25 to 30. You cannot average out like this, isn't it? So in this case we have to try to find out the mid value of the x, alright. The class intervals which are given, we have to find out the mid value of that particular class interval. So when we are talking of class interval, let me tell you, as I said 0 to 5. So the first value which is given 0, this is called lower limit and it is generally denoted as L1, and 5 would be upper limit which is denoted as L2. Alright. So L1 is in this case 0 and L2 is 5. In the next data, if you say the next value or the same variable, it is 5 to 10. That means in this case L1, that is lower limit, is 5 and upper limit is 10, L2 is 10. How do we get the mid value? Frequency is given in the data set, which is 0 to 5, 3 salesmen, 5 to 10, 12 salesmen, 10 to 25, 25 salesmen, and 25 to 50, 10 salesmen again. So frequency is given, number of observations are given, and the summation of observation in this particular example is 50. So summation f is 50, that means n is 50, because summation f is what? Nothing but n. We are denoting it with the help of n. Alright. Now since we have to take mid value of x, x is 0 to 5, 5 to 10, 10 to 25 and 25 to 30. So what do? We add up lower limit and upper limit and we divide it by 2. First we take the average of the class interval. Alright. So what are we doing? 0 plus 5 upon 2, lower limit plus upper limit upon 2, and we get the value 2.5. Alright. In the next case 5 to 10, that means lower limit is 5, upper limit is 10, L1 plus L2 upon 2, that means 5 plus 10 upon 2, and the value that you get is 7.5. Again 10 to 25, the mid value would be 17.5 as 10 plus 25 upon 2. And in the similar way for 25 to 50 you get the value of 37.5. So now you have got a value on which you can do your mathematical operations, isn't it? 2.5, 7.5, 17.5 and 37.5. Now you have to multiply your frequency with this value which we can denote as m. You can give any name to it. You just have to write that m is so and so, that m is midpoint. Alright. So 2.5 into 3, that comes 7.5, 12 into 7.5, it is 90, 25 into 17.5, it is 437.5, and 10 into 37.5 is equals to 375. Now we have to do the summation of Fm, and summation of Fm, if you add up all the numbers, Which numbers? 7.5, 90.0, 437.5 and 375.0. If you add up, you get a value of 910. So what do? Simple. Summation Fm, you were writing x. Now since you have converted your x into m, so formula would be mean is equals to summation Fm upon n. That means summation Fm is 910 and n is 50. So when you divide 910 by 50, you get the value of 18.2, and in this case the mean value is 18.2. Alright. So this was direct method. Now as I said, if you want to reduce, this is the small number that I have given in this data set, but in real life the data set, the information or the numbers of the observations would be very many, would be huge. So in that case, if you want to reduce, shorten the amount of calculation that you are doing, what you can do, you can increase the step and shorten the calculation. So that would be shortcut method. Let us see how can we calculate mean in continuous series with the help of shortcut method, right? Are you ready? Are you clear up till now? Shall we move? Alright, let us move. Now we try to calculate mean through shortcut method. Class intervals you already know. Frequency is already given 3, 12, 25, 10, right? This is the frequency, and the total number of observation or summation f is equals to 50, which is n. Alright. Shortcut method, what we did in discrete series, we assumed a number, a value as a mean, and then we tried to minus the value of x with the assumed mean. This is what we tried to find out the deviation of x from the assumed mean. So here in this case also we will find the deviation of x, in this case m, alright, with assumed mean. So as I said, you can take any value as assumed mean, the answer that you will get will be similar, but just to ease your calculation, as I suggested, you should take the middle number. So in this case I have taken assumed mean as 17.5. So what do? You have calculated the mid value 2.5, 7.5, 17.5 and 37.5. Now you have to find out the deviation of this mid value from the assumed mean. So a minus mid value. A minus mid value in this case would be, in first instance it would be 2.5 minus 17.5, and the answer is minus 15. 7.5 minus 17.5 and the answer is minus 10. 17.5 minus 17.5 and the answer is 0, and 37.5 minus 17.5 and the answer is 20. You've got the data, right? Now as usual, what you need to do? Now this data is to be multiplied with the frequency. So minus 15 into 3 is equals to minus 45, minus 10 into 12 is equals to minus 120, 0 into 25 is 0, and 20 into 10 is 200. And you have to find out the summation of this particular column, which is FD, and your summation is coming as 35. Alright. So now as in the case of discrete series, the formula would be x bar or mean is equals to assumed mean plus summation FD upon n. In this case the assumed mean is 17.5 plus summation FD is 35, total number of observations, that is n, is equals to 50, and you get the answer 18.2. So earlier also, with the direct method also you got the answer 18.2, and with this help also you get the answer 18.2. So this was shortcut method. There is another method which is called as step deviation method. Here you can shorten the calculation even further, but you have to increase the step, one more step. So number of column would be added. All right. Are you ready for that? Have you practiced till here with me? All right. If you have not done, please do it afterwards. Now we will talk of the other method, which is step deviation method. So with the same data set, now we will try to calculate the mean through step deviation method. Up to column 1 and 2 and 3, it must be clear to you how we have derived. All right. In this column also, even D you have known how we have got D, minus 15, minus 10, 20. If you don't remember, you can go reverse and see how do we calculate this. Now in this we have to add one more column, and that is we need to calculate step deviation of m. That means we need to find out a value which can divide all the values of m, a common value, a common factor which can divide all the values of m. So, in this case the common value is 5, alright. So, we have taken what? 5, alright. So, let us calculate d dash. As I have said that you have to take a common factor which can divide all the values of m, which is minus 15, minus 10, 0 and 20. So, in this case what would you do? You try to take a common factor which can divide all these values. So, we have taken a common factor as 5. So, if minus 15 divided by 5 is minus 3, minus 10 divided by 5 is minus 2, 0 divided by 5 is 0 and 20 divided by 5 is 4, alright. So, you get the d dash, the values of d dash as minus 3, minus 2, 0 and 4. Now, your new value is d dash and you have to compute f into d dash. Earlier what you were doing? You were calculating f into d. Now, you will calculate f into d dash, alright. So, f into d dash is coming, 3 into minus 3 is minus 9, 12 into minus 2 is minus 24, 25 into 0 is 0 and 10 into 4 is 40. Then same, you have to calculate the summation of this particular column and this column is f d dash. So, summation of f d dash is 7. Since we have taken a common factor here, the formula will also try to incorporate that common factor. So, now the formula would be mean is equals to assumed mean plus summation f d dash upon n into c, and c is what? Common factor. So, in this case you have to find out mean. So, mean is equals to assumed mean which we have taken as 17.5 plus f d dash which is 7 divided by number of observations which is 50 into common factor which is 5, and you get the answer 18.2. So, the mean of sales is rupees 18.2 thousand per week in this, for this particular data set through all the 3 methods that we have seen. So, learners, we have seen till now how do we calculate arithmetic mean in 3 kinds of series, which is individual series, discrete series and continuous series. In the next session we will talk of median. Thank you.